Hi, my name is Ariana.
And my name is Taylor.
And we are both second-year biology majors, and we're going to go over Chapter 4.4, Number 1 from the workbook.
Oh no, Ariana! You just spilled 85 milliliters of 1.5 molar sulfuric acid on your lab bench, and you need to clean it up immediately. Right next to you, there's a small jar labeled 15 grams of sodium bicarbonate. Will this be enough sodium bicarbonate to neutralize the spilled sulfuric acid?
I don't know, Taylor. Let's see. This problem has a few concepts built into it. One of these main concepts is limiting reactants. A limiting reactant is a substance that is totally consumed when a chemical reaction is completed. So we have to determine whether the sulfuric acid is the limiting reactant in this case, or the sodium bicarbonate.
The first step to this problem is writing the reaction that is occurring. We have sodium bicarbonate reacting with the spilled sulfuric acid to neutralize it. This forms sodium sulfate and carbonic acid. But remember that the carbonic acid will further form water and carbon dioxide. Now that we have all of our reactants and products, don't forget to balance the equation.
The next step of preparation for this problem is going to be listing out all of the information that we're given. The first thing it tells us is that we have 85 milliliters of 1.5 molar sulfuric acid. And the second thing that it tells us is that we have 15 grams of sodium bicarbonate.
Our goal is to compare the two reactants, but right now one is in grams and the other one is in milliliters. So just looking at this now would be like comparing apples and oranges. There are multiple ways to compare these two reactants, but what we are going to do is convert our milliliters of sulfuric acid into grams of sodium bicarbonate to find out how much sodium bicarbonate we would need to fully complete the reaction. In order to relate the two reactants, we need some sort of ratio between the sulfuric acid and the sodium bicarbonate. If you recall back to the balanced equation we wrote out previously, you can see that we have specified amounts of moles of sodium bicarbonate and moles of sulfuric acid. Remember, there's an unwritten coefficient of 1. We can use these integers to relate the two reactants in what we call a mole-to-mole ratio.
Alright, now let's start solving this problem. We have milliliters of sulfuric acid, and we want to get that into liters, so we can just go from milliliters to liters using a simple conversion. And then we're going to go from liters of sulfuric acid to moles of sulfuric acid using the molarity that it gave us in the problem. And I'm specifying that it's sulfuric acid every time, not to be repetitive, but that it'll get really confusing if you don't clarify what molecule you have moles for. Because this next step, we're going to go from moles of sulfuric acid into moles of sodium bicarbonate. And this is the really important mole-to-mole ratio that Taylor was talking about earlier. Now we can go from moles of sodium bicarbonate into grams of sodium bicarbonate, which is what we wanted to solve for. And that's just going to be using the molecular weight from the periodic table. And just like other dimensional analysis problems, you're going to want all of your units to cancel out so that you're left with the one that you're solving for. So milliliters cancels out, liters cancels out, moles of sulfuric acid cancels out, moles of sodium bicarbonate cancels out, and we're left with grams of sodium bicarbonate, which is exactly what we wanted.
After you have the steps written for you, now let's fill in the numbers. We started with 85 milliliters of sulfuric acid. And you know that there are 1,000 milliliters in 1 liter. There is also 1.5 moles of sulfuric acid in 1 liter, and 1 mole of sulfuric acid for every 2 moles of sodium bicarbonate. And there's 84 grams of sodium bicarbonate in every mole.
Once you multiply that out, you get 21.42 grams of sodium bicarbonate. Now we want to go back and compare this to what we're given. It says that we have 15 grams of sodium bicarbonate next to us on the counter. And it looks like because 15 is less than 21.42, we do not have enough sodium bicarbonate to completely neutralize the sulfuric acid that we've spilled. because you need 21.42 grams of sodium bicarbonate to neutralize it. Now, thinking back to what we said about limiting reactants, turns out that sodium bicarbonate is the limiting reactant in this problem, and that's because it's completely used up in this reaction.